Hey everyone, welcome to Revolution's Games Academy. In today's video, we're diving into one of the most essential mechanics for creating immersive games in Unity, raycasting and line of sight for AI characters. Whether you're building stealth mechanics or AI that reacts to the player, understanding raycasting is key. Let's get started. What is raycasting in Unity? Raycasting is a technique in Unity that simulates an invisible laser beam shooting from a specific point in the game world. The ray travels in a straight line and detects objects it collides with. This mechanism is widely used in games for detecting obstacles, enabling AI behavior, and implementing shooting mechanics in both first-person and third-person games. Now, let's see a simple example for recasting. We'll start by creating a cube. Right-click in the hierarchy panel, go to 3D Object, and select Cube. This cube will act as the origin point for our raycasting. Next, duplicate the existing cube by pressing Ctrl+D. This new cube will act as an obstacle. To assign it to a new layer, click the Layer drop-down in the inspector, select Add Layer, create a new layer, and assign it to the obstacle. Let's adjust the positions of both objects in the inspector window to set up the scene properly. Finally, we'll write a simple script to demonstrate how recasting works. To do this, click the Add Component button in the inspector window, give the class name, and then click the Create and Add, double-click on the script to open it in your code editor. First, we need to declare references for important elements, like the raise distance and the obstacle layer mask. These references will help set up the logic for detecting if the player is visible to the enemy. Next, we'll write the update method to check for the presence of obstacles using raycasting in real time. In Unity, raycasting is implemented using the physics raycast method. This method sends a ray and checks if it collides with any object. If a collision occurs, it returns detailed information about the hit object. The function includes several parameters. The origin is the starting point of the ray, typically set to the position of an object, such as the player or an AI character. The direction defines the ray's path and is calculated by subtracting the origin's position from the target's position. The raycast hit structure stores detailed information about the object the ray collides with, including properties like the object's name and position. Now, let's take a look at the script. This script demonstrates how to use raycasting in Unity to detect objects in front of an object. A ray is cast from the object's position in its forward direction, traveling a specified distance. The ray interacts only with objects on the layers defined by the ray layer mask. In the update method, the ray is visualized in the scene view using debug draw ray and checked for collisions with physics raycast. If the ray hits an object, the script logs the object's name. If it doesn't hit anything, it logs that the ray missed. This is a simple way to detect objects and can be used for mechanics like obstacle detection or targeting. Good, now let's go to Unity Editor and assign the layer mask to the script in the inspector window and run the game. But before we do, make sure the gizmos option is enabled in the top right corner of the game and scene windows. This will allow us to see the ray. Oops, sorry. We assigned the script incorrectly to the obstacle. We need to attach the script to the origin cube and assign layer mask and then adjust the cube's rotation. Now let's play the game. Now you will notice a red line in both the scene and game windows. This represents the raycast. In the console window, you'll see debug messages. When the origin ray hits the obstacle, it will log that the cube has been hit. If I move the obstacle outside the maximum distance, the debug will update to show ray missed in the console. Great, we have learned about the raycasting. Now we will see about line of sight. What is line of sight in Unity? Line of sight refers to the ability of one object, such as an AI character, to see another object, typically the player, within a defined field of vision and range. This mechanic is crucial for creating realistic AI behavior in games, such as enemy detection, stealth mechanics, or even NPC interactions. Now, let's look at a simple example of line of sight. First, we need to create an enemy object and a player object. Then we'll create the line of sight script to the enemy object to enable it to detect the player. I will use the same cubes to represent the player and the enemy. We'll update their name and assign a layer to the player so the raycast can target it correctly. And I will also create a wall by duplicating player to hide the player and demonstrate how the enemy stops detecting the player when blocked by the obstacle. Let's create and assign the new layer to the wall. Great, now let's create a script for the line of sight mechanic. We will name the script line of sight and open it to start writing the code. First, we need to declare references for important elements, such as the player's position, the maximum view distance, the field of view angle, and the layer masks for obstacles and the player. Next, we'll write the update method. This method will calculate the direction to the player, check if the player is within the field of view angle, and use raycasting to detect any obstacles in the line of sight. In real time, it will decide whether the player is visible or hidden, and we'll use debug messages to confirm the results. Finally, we'll use the enDraw gizmos method to visualize the enemy's field of view in the Unity editor. This involves drawing two yellow lines that represent the boundaries of the field of view. It's a handy way to debug and refine the detection system during development. And in 2D, the logic for line of sight is similar to 3D, but uses Physics 2D Raycast for raycasting. Now let's go to Unity Editor and assign the player and assign the layer mask for player and obstacle in Inspector and run the game and see how the line of sight works. Before that, we can adjust the wall or obstacle placement in the scene to ensure it blocks the player's line of sight. Here, you can see that when the player enters the enemy's field of view, the debug message will be printed in the console. And when I'm placing the wall between the player and enemy, a new debug message will appear in the console window. Okay, guys, and that brings us to the end of today's tutorial. We covered how to use raycasting for line of sight detection and how to debug visibility with messages in the console. If you found this guide helpful, please give it a thumbs up and consider subscribing for more Unity tutorials. In the next video, we'll dive into advanced topics like object pooling. Thank you for watching, and I'll see you in the next one. Happy game developing, guys.